Page 6 of Properties of Curves. Here we are at 16C, stationary points. If you look at the reading, first thing they talk about is when you have a stationary point, what is the value of the derivative? And remember, a stationary point is like if you have a curve, it's the place where you can balance a ball, for example. Even if it's very difficult to balance the ball, you can balance the ball. So like here, obviously, it's pretty easy to balance a ball. Here, maybe not so easy to balance, but the fact that the ball might go left, might go right is already kind of balancing it, right? Obviously here is not. The ball is immediately going to go to the left, right? So in this picture here, the two stationary points would be as drawn, okay? And the derivative at these 2 points, if you draw a tangent, you can see that the derivative, or the gradient, is 0, so it's 0. What are the 3 types of stationary points? The 3 types of stationary points are global minimum, or not local minimum, local maximum, and last of all, a stationary inflection point, which I'll show you what that is in a minute. You saw in the investigation, but we'll remind you. So on the graph below, mark the following points: global minimum, global maximum, local minimum, local maximum points. Now, I'm going to mark the local minimum would be this point here. The local maximum would be that point here. And the global maximum, now the global maximum does not necessarily have to have a gradient of 0. So here's the global maximum. When you're finding a global maximum, what you do is you find all the local maximums, you see which one is the highest, and then you also find the endpoint values and see which one of those is the highest. And so sometimes the endpoint is the global maximum, global minimum, and in this case, that is true. There's the global minimum, there's the global maximum. They're endpoints. They're not stationary points. Consider the following graph, which has a restricted domain of -5 to 6. So it asks, okay, yeah, that's what they're talking about, the graph here. Okay? All right, next. Is the vertex of a parabola y equals x squared a global or local minimum? Okay, here is a parabola y equals x squared. They're talking about the vertex right here. Is that a global or a local minimum? Well, can you balance a ball there? Yes. So it's a local minimum, yes. Is it a global minimum? Is it the lowest point on the curve, including endpoints? Yes. Also yes. So it's both. Okay. At the right, we see the cubic function f of x equals x cubed. Mark the point on the function where the derivative is 0. Okay, where can you balance the ball? Right there. Or where is the derivative 0? Right there. Okay. Mark the point on the function where the derivative is 0. Is it neither a minimum nor a maximum? It is neither a minimum nor a maximum. What kind of point is it? It's a stationary inflection point that we were talking about before. Stationary inflection points do have derivatives of 0, but they are not local minimums or local maximums. On the right, it looks kind of like it would be a minimum, and on the left, it looks kind of like it's a maximum. Okay. It's where the curve kind of, instead of curving one way, it starts curving the other way. Okay, now we're looking at a new graph here, which has critical points at -2, 1, and 3. What I mean by critical points is the gradients at these points are 0. Okay, so they're either going to be local minimums, local maximums, or stationary inflections. Mark the number line with a sign diagram showing when the function above is increasing and decreasing. Mark it with zeros when the function is neither increasing nor decreasing. Okay, so at the stationary points, it's always 0. When it's increasing, like here, it's positive, increasing here, positive, decreasing here, negative, increasing here, positive. Okay, always going from a left to right direction as far as like determining whether it's increasing or decreasing. All right. One thing about their notation is when they have this not dotted line here in the middle, I think that what that means is it's a 0 slope. So think of this as a 0 here and a 0 here. And so what they're saying is, what kind of function, not point, what kind of function has a sign diagram to the left or what kind of functions, because maybe there's two different ones. So like the first one, what it's saying is, hey, you're increasing, and then you have a flat part because the gradient becomes 0, and then you're increasing again. And then this other one is like you're decreasing, and then you're flat, and then decreasing again. So it looks kind of like a x cubed function, right? So like an x cubed function goes like that or like that. Okay. What additional check do we have if we are finding global maximum, global minimum on a domain that is a limited interval? Okay, remember what I said before. Global maximum, global minimums, you have to check all the local maximum, local minimums to see which one is the global maximum, global minimum, the highest maximum, the lowest minimum. But you also need to check the endpoints. So you check the endpoints. Check the endpoints. Okay? And if you check the endpoints, then you've really made a complete check to find global maximum, global minimum. And that's it for this page.